Ever wonder why heavy objects stay completely still until you struggle to push them, or why thrown objects eventually fall back to the ground? It all comes down to one fundamental physical concept: force. At its absolute simplest level, a force is simply a push or a pull acting upon an object. Whenever two physical objects interact, a force is actively exerted on each of them. Forces are the ultimate catalyst of motion. They can cause a stationary object to start moving, speed up, slow down to a complete halt, or abruptly change its direction. Without an external force acting on an object, anything at rest stays sitting right where it is, and anything moving keeps moving in a perfectly straight line forever. Physicists divide all forces in the universe into two major categories based on how they interact: contact forces and non-contact forces that operate over distances. Contact forces require direct physical touch between objects. Whenever you kick a ball, write with a pencil, or push open a door, you are applying a direct contact force. Friction is one of the most common contact forces you encounter daily. It acts in the direct opposite direction of motion whenever two rough surfaces rub together. Another vital contact force is tension, which travels through cables, ropes, or strings when pulled tight by forces acting from opposite ends of the structural line. Non-contact forces work their magic across empty space without requiring physical touching. Magnetic fields can pull or repel objects across a noticeable distance effortlessly. Gravity is the most famous non-contact force. Every object with mass exerts a gravitational pull on every other object, constantly pulling massive bodies together. Because Earth has massive bulk, its gravitational pull keeps your feet firmly planted on the ground, controls oceanic tides, and holds our entire atmosphere in place safely. Forces can also be balanced or unbalanced. When equal forces act on an object in opposite directions, they cancel out, resulting in zero overall change in motion. When forces acting on an object are unequal or unbalanced, a net force created in one direction forces the object to accelerate toward the stronger pulling side. Our entire modern understanding of physical motion rests on three foundational laws formulated by legendary scientist Sir Isaac Newton way back in the late 17th century. Newton's first law, often called inertia, states that objects naturally resist changes in their state of motion unless acted upon by an external net force. Newton's second law gives us the iconic mathematical relationship showing force equals mass times acceleration, showing how weight impacts movement rates directly. Pushing a light shopping cart causes fast acceleration, but pushing a heavy motorized vehicle with the exact same force yields slow, barely noticeable movement. Newton's third law reveals that for every single action force, there is always an equal and opposite reaction force pushing back with identical strength. To measure force precisely in science, we use a unit called the Newton, named directly after Isaac Newton to honor his immense contribution to physics history. From cosmic gravity holding planets in orbit to small friction stopping your bicycle, force shapes every single motion across our vast, incredible universe.